Today, lesson 11b, we start dealing with items titled inequalities. Inequality could be interpreted as not necessarily equal. Our focus as of late has been equations and situations where we may need an equation to find the solution to that problem. And now we enter the world of inequalities. All right, so today's lesson is really based on something you should have learned in 6th grade, but I know from experience, depending on who you have, it may have been done better than perhaps having someone else. We need to make sure that we're clear on all of this stuff. So first of all, a little bit of vocabulary. An inequality is a mathematical sentence that contains less than, greater than, less than or equal to, greater than or equal to, or even perhaps not equal to. So that's what all of those symbols mean. So once again, this symbol means is less than, this one means is greater than, this one means is less than or equal to, this one means is greater than or equal to, and this one means is not equal to. Now there are other phrases that mean or represent the same ideas, and that's really what 1 through 8 is all about. So 1 through 8, this should be review from 6th grade. So with your shoulder partner, write inequalities for each statement below. I've already done an example for you. So the example states that the Garcia family car seats 7 at most. And one interpretation of 7 at most is, if I use the variable x is less than or equal to 7. Okay, so with your shoulder partner, go ahead and do 1 through 8. I'll get back to you in about a minute to 2 minutes. So number 1, a school bus can seat at most 48 students. That could be interpreted as, and I'm using the variable s in this one, because we're talking about school bus seats. S is less than or equal to 48. You can use any variable that you want to. One thing I want to make clear is that this also means the same thing. 48 is greater than or equal to S. Those represent the same idea. Okay? Same idea. So if you had things backwards like that, I just wanted to bring that up. All right, so number 2, in many states you must be at least 16 years old to obtain a driver's license. That could be interpreted as A is greater than or equal to 48. Number 3, it isn't safe to use a light bulb of more than 100 watts in many light fixtures. That would be something like W is greater than 100. Some of you may have thought it was talking about when it is safe. I was interpreting it as when it's not safe. Okay? So if you interpret it as is safe, it would be like W is less than or equal to 100. Yes?
For number 2, where does the 48 come from?
I don't know. That should be a 16. Thank you. I'll fix that right at the end of this. Number 4, no less than 250 of parents attended back to school night. That might be something like P is greater than or equal to 250. Number 5, you must be no more than 15 years old to attend the middle school dance. A is less than or equal to 15. Number 6, so as to not break the sound barrier, a plane must travel below 760 miles per hour. Maybe something like S is less than 760. Number 7, children must be above 48 inches tall to ride the roller coaster. That would be something like H is greater than 48. Now I'm noticing a couple of you wrote H is greater than or equal to 48. Why does that not work?
Because you have to be above 48 inches tall. It doesn't say you can be 48.
Yeah, it has to be above 48, not 48 or above. So you have to pay attention to things like that. And then number 8, you must have fewer than 3 tardies to get a satisfactory citizenship grade. So that would be something like T is less than 3. Once again, we're not including 3 there. And once again, this should be 16 right there. Okay, so here's the deal. Some of you, as I walked around, you understood what these terms meant, at least, more than, no more than, below, above. If you think about them, you should. But what if you don't? Well, that's what this table right below that is all about. Common phrases that represent inequalities. Well, we know that the less than symbol, the most common meaning is less than. But there are other common word phrases that mean the same thing. And that doesn't mean that these are the only ones, but these are other common ones. So here are a couple right here. And really there should be the word is in front of each of those. Is fewer than and is below. And we saw below within one of those first 8 problems. The greater than symbol, is more than, is above. And I think we saw a couple of those in that first 8. Less than or equal to, at most, no more than. Greater than or equal to, at least, means the same thing, or no less than. So I'm going to stop for a second. These are common word phrases that mean or represent these ideas of inequalities. They're not the only ones, but they're some of the most common ones. And I think if you go and look in 1 through 8, most of those are found in 1 through 8 because that's how common they are. All right, so let's go to the back side of our notes. And I'm going to put up a bunch of examples here. And all I'm doing here is just adding these to those lists. All right, so I'm going to put up a bunch of examples here. Here's what you're going to do with your shoulder partner. All 5 of them, what you're going to do is you're going to turn to your shoulder partner and read each of the following to each other using correct vocabulary. Try and say it in as many different ways as you can, and that was one of the reasons why I had you fill in that table beforehand. Okay? Turn to your shoulder partner, read each of those in as many different ways as you can, all 5 of them. All right, so one way of saying that 5 is less than 7 is just that. 5 is less than 7. What's one other way of saying it? Yes? What's that? 5, yeah, and we really should say 5 is fewer than 7. That's why I said when we were filling in those word phrases, we really should have the word is in front. What's another way of saying that?
5 is less than 7.
Well, I already have that one.
Why did I say that? 5 is below 7.
There we go.
I was thinking 5 is less than 7.
Okay. All right, so I'll take the cheap one here, the easy one. X is greater than negative 12. Give me another one. Josh.
X is more than negative 12.
X is more than negative 12. Another one?
X is larger than negative 12.
Okay, and that was one we didn't even put in there, but that's more along the lines, and that will work, but it's more along the lines of X is above negative 12. All right, I'll take the easy one here. C is less than or equal to 3. Somebody give me another one. Go ahead.
C is at most 3.
C is at most 3. And then there should be one other one.
C is no more than 3.
C is no more than 3. Good. I'll take the easy one. 6 is greater than or equal to 2. Another one.
6 is at least 2.
6 is at least 2. The great thing I like about how you guys are phrasing them, they're going in the same exact order as my transitions here, so I don't have to bypass anything. What would be one other one? Yeah.
6 is no less than 2.
Good. And then, of course, there's really only one way of saying this. Negative 8 is not equal to negative 1. Okay. So now, here is an inequality that is x is less than or equal to 2. Think of some solutions to that inequality. Remember, when we're finding the solution to anything, we're trying to find number or numbers that we can substitute for the variable that will create a true statement. Turn to your shoulder partner and come up with some solutions to that inequality. Quickly, you got about 20 seconds. All right, somebody give me one solution. Negative pi, I like that one. Somebody give me another solution.
Negative tall.
Negative what?
Tall.
What's that?
It's 2 pi. Haven't you guys ever heard of it?
No, I haven't. No. Is it slang for it or something? Somebody give me something else. Negative 73. So my next question is this. Those all are correct. How many solutions do you think there are? A lot, or an infinite number. And that's where the idea of graphing inequalities comes from. And so how can we show that by graphing or graphically? Well, we typically would have a number line, and when we graph things in here, we don't have to write all of those numbers on there. When we graph solutions to inequalities, all I care about is having 0 in the middle. There's a reason why I have all those numbers up here for this one, but here's how we would typically do it. We would put 0 in the middle, and then whatever number is mentioned within our inequality, which happens to be 2, well, 2 is on the right-hand side of 0. So typically, those are the only numbers that we would need to show when we're actually graphing a solution to an inequality. But for this one, the reason why I'm doing this is this. And that's because 1 is a solution to x is less than or equal to 2. So is 0. So is 2 for that matter, because it is less than or equal to. So are all of those numbers. But not just that. Also, decimal or fraction values in between are also solutions, like 1.5 or 1.8 or 1.999 and so on. So all of those numbers to the left of 2 on a number line are solutions, including the number 2. And so that's why we represent graphically the solutions to x is less than or equal to with a graph like this, because that graph is telling us that from 2 on down to the left on a number line, every single one of those numbers will create a true statement. Yes?
Isn't there something we have to do with the dot since it's less than and equal?
Or equal to. One or the other. Yeah.
Don't you have to do something with the dot at the 2?
Well, we're going to come to that idea, but it should be closed in because we're including the 2. Yeah. Sometimes we don't close it in, but we'll talk about that in just a second. All right, so that graph represents all the solutions to that inequality, and you should have graphed that in your notes. Now, how about x is greater than negative 3? Well, if we did the same sort of thinking, negative 2 makes a true statement. So does negative 1. So does 0. In fact, all of the numbers to the right of negative 3 make a true statement. But in this one, does negative 3 make a true statement? No, it does not. So that's the case where we would use an open circle because it's to the right of negative 3 on the number line, but we're not including that negative 3 because negative 3 doesn't make a true statement. So open circle over negative 3 with an arrow to the right. All of those represent the solutions to that inequality. Okay? So the standard rule is this. When we are graphing inequalities, with the less than or greater than symbol, we use an open circle. When we're graphing less than or equal to or greater than or equal to, we use a closed circle. Now the question is why? Well, I just kind of explained that. We use an open circle when we're not including the number. We use a closed circle when we are including the number, and that is the exact reason why. Okay? All right. Can I get all of you to graph number 1 and number 2? And remember, when we're drawing our number line, we need 0 in the middle, and whatever number is mentioned within our inequality, since negative 1 is to the left, we would need to plot that there and then draw the graph that represents the solutions to that inequality. So, number 1. Closed circle above negative 1 because we're including negative 1, and all the numbers that are less than negative 1 on the number line are to the left of that, and so that's what our graph should look like. Okay? All right, number 2. Everybody try number 2. So number 2, we draw our number line, we plot the open circle over 4 because we're not including 4, and all the numbers that are greater than 4 on a number line are to the right of that. So that's what our graph should look like for number 2. All right, so now in number 3, 4, and 5, you actually have a sentence where the first thing you're going to have to do is you're going to have to convert the sentence to an inequality and then graph that inequality. Okay, so in these 3 problems, we're kind of putting everything together that we've talked about so far. So go ahead and do number 3, 4, and 5. Once again, convert the sentence to an inequality, then graph that inequality. Number 3, a number x is at most 3. That translates to the inequality x is less than or equal to 3. As far as a graph goes, that would be a closed circle over 3. All the numbers that are less than 3 on a number line are to the left of that, so we draw an arrow to the left. Number 4, a number x is above negative 2. That translates to the inequality x is greater than negative 2. As far as the graph goes, that would be an open circle over negative 2 because we're not including negative 2. And all the numbers that are bigger than negative 2 on the number line are to the right of that, so the arrow goes to the right. And number 5, a number x is fewer than negative 4. That translates to the inequality x is less than negative 4. The graph looks like this. Open circle over negative 4 because we are not including negative 4, and all the numbers that are smaller than or less than negative 4 on the number line are to the left of that, so our arrow goes to the left. All right, last thing for today. We are given a graph, and from that graph, we have to write an inequality. Let's do number 6 together. What would number 6 be in terms of an inequality? What would that look like?
X is less than 2.
That would be x is less than 2. So the inequality is, and I have a sentence frame up here for when we shoulder partner, the inequality is x is less than 2. All right, quickly finish those up, and then we'll shoulder partner all 5 of them that are left, and then we are finished for today. Number 7, the inequality is x is greater than or equal to negative 1. Number 8, the inequality is x is greater than 0. Number 9, the inequality is x is greater than negative 9. Number 10, the inequality is x is greater than or equal to 15. And number 11, the inequality is x is less than or equal to 24. All right, we are finished for today.